So this equation is giving the your this is the with the change of the delta with respect to time t. ठीक है? Change of the delta with respect to with the acceleration delta. So this equation is known as the swing equation. This is the swing equation. ठीक है? So in order to at any instant, what will be the value of delta? So we can find using this equation. ठीक है? So this is the second order equation. So the solution is not easy in case if the machines are more. So we can use some techniques which in case of steady state condition, your delta is gradually changing. So you can find. But in case of in case of transient stability, so there is sharp change at which instant it will be there. So means if you are making the calculations, it will be very time consuming. So we use some techniques. We use some in case of transient stability. We use some techniques. ठीक है? Those techniques are for the analysis of the transient stability study. We use the equal area criteria. Means in order to know that whether you are after the disturbance, your machine is stable or not stable. So for that we use the equal area criteria, or we can use the numerical techniques in order to find the delta. ठीक है? So we had a point by point method, we had a Euler method, different methods we have. So we can apply those methods also. So we have this from this equation. This is equal to your alpha, or we can say it is alpha m into alpha is equal to psh minus pe. So from this is the alpha. So alpha is equal to d square psh minus pe divided by m, or m alpha psh minus pe divided by m. So we have a different conditions here. Means if your acceleration is 0, if alpha is 0, then this m alpha is 0. ठीक है? This m alpha will be 0. So no acceleration. So under that case, your shaft power or mechanical power is equal to electrical power. So your machine will be under the steady state condition. Now if alpha is greater than 0, if alpha is greater than 0, so under that case means your mechanical power, in case of generator, your mechanical power will be greater than the electrical power. And in case of if you want to find the means in case of the motor, it is reverse. Yeah, this is actually giving the acceleration power. Acceleration power. So in case of generator, we take the mechanical power minus P, and in case of motor, we take the P minus PL. ठीक है? जेकर मोटर का केस लेने ਉਹਦੇ ਵਿੱਚ ਕਿਉਂਕਿ we are giving the input in case of the motor, the P is the input, P is the cause of the rotation of the your machine. ठीक है? If you give the more power, we are giving the more energy. So that is the acceleration. ठीक है? Means and if you put the more and more load, your rotor is lagging behind. Your rotor is slowing down. ठीक है? So means in case of generator, it is the case of generator. Means if your alpha is greater than 0, if alpha is greater than 0, your uh, mechanical power is greater than the electrical power, and it is the acceleration. Acceleration means your machine speed is increasing, so your delta is also increasing in case of the generator case, and reverse will happen in case of the motor case. It will reduce in case of motor. And if alpha is less than 0, so it is a de-acceleration. De-acceleration. So it is the different cases we have. So we can also have the number of machines in parallel. Normally we have the machines, number of machines are running in the parallel. So we can have the 2 machines, 3 machines, and in case of real power system, we have a large number of the machines. And one disturbance in case of the your parallel connected machine is known as a coherent operation. In case of the coherent operation, your delta is simultaneously changing. Means all the value of the delta is changing simultaneously. All the change in delta in all the machine is same. And in case of incoherent operation, the different machines change differently. Okay? So we can also develop the your equivalent inertia constant, equivalent angular inertia constant, equivalent value of m, equivalent value of h, because we define the inertia constant in terms of m or h. Okay? So, but I think in your syllabus it is not mentioned. So it is a simple. If we can, it is a very simple. If you want to cover, it is a we are two